So hello Sailing Finland viewers and welcome back to my series on 8-meter yachts. And today we're going to be looking at the engine of the 8-meter yacht, that is the sail. So I'm visiting at a sailmaker called VB Sails, and I'll be following along with the development of a sail for an 8-meter yacht, Katrina. And you'll get to see a little bit about the design, but also how the sail is then actually made here at the loft. So I'll be talking today to Mikko Brummer, who's the CEO of the company and is probably one of the most knowledgeable persons in Finland on how to design racing quality sails. So let's see how 8-meter sails are being created. Okay, Mikko, thanks for having me here. How do you, by the way, say your name is WB, but do you say VB?
We say VB sales, yeah. Or the customers call us VB, so it's VB sales.
Yeah, Finns don't know the W.
No, W is too difficult.
Okay,
VB is good.
Yeah. So, give me a little bit of background on VB sales. How did it start?
It started about exactly 50 years ago, actually, when we were sailing 505s and 470s. And we wanted to make sails for ourselves. And we did, and after a couple of years we sailed in the Olympics in Montreal in 1976 with those sails. And then really the sail started that way. And we specialized on sails for the Olympic classes, but nowadays we do for any kind of boats, big boats, keel boats, cruising boats, and still some. Not the Olympic classes, because we are not allowed to make for them any longer, but the old former Olympic classes are still very important for us.
Okay. So now, today we're talking about 8 meters. So I just went to Red Sky and they told me that, they make sure that the certificate for the boat is accurate, and that includes then specifications of the sail. So I come here now and what happens next?
Okay, so designing a new mainsail for the 8-meter, we start with what we would start when we do any new sail for any boat. We look in the database what we have done, if we have done something earlier for that boat or for any similar boat. And now in the case of Katrina, we did the first sails in 2013, 12 years ago, so we have a good starting point from their old sails.
So when you did the first sail, so have you been on board measuring something, or is this based on just the drawings?
I think it's based on the drawings and the measurement certificate, where we have very good measurements for the.
Okay.
Rather often we go on board also. And we need to go for cruising boats, for instance. You need to go on board to take the measurements, because you can't trust the sail plan, original sail plan of the boat. But for for racing boats, the sails, mast, and rigs are measured quite accurately, so you can usually trust the certificate.
Okay.
And build up on the certificates.
Okay.
But in this case, when we have made the sails before, we know that they fit the boat, so that's a very good starting point already. And it helps us with that.
So what has happened now in the last over 10 years? So will you be making some modifications now to the sail?
The designs they evolve all the time, and they have evolved some in the last years also. So the new sail will be a little bit different from the old one, but still it's a good base to start with. We have in the database here sails. All the sails that we've done since 2017, 1,000 sails. So there's plenty of data to look at. And in case of Katrina, we also have some photos of their old sails while sailing. We can look at the photos to see what we think about them. The original sails from 2013 were really good, powerful, rather light, very much completely racing oriented, film-to-film material. Now they want something a little bit less powerful because the boat has lots of sails. It's easy moving in the white areas and more difficult when the wind builds up. And also they want sails that last a little bit longer. At the time, these film-to-film sails were very popular because they make the fastest, widest sails that you can do, but they don't last long. So nowadays, most 8-meter sails and most racing cruising sails, if they are laminates, they are done with taffeta cloth on both sides, or one side or both sides, to make them last longer.
So when you say longer, what times are you planning now for it to last? 5 years, 10 years?
Yeah. The materials have evolved actually quite a lot also in the last 10 years, so that nowadays the old sails used to be film materials. Nowadays we do sails without any film at all. They are filmless, just the fibers and some bonding material to bond the fibers together, and then white taffetas on the fibers to protect the fibers.
So the fibers are carbon fiber, if I'm right?
The fibers are a mix of carbon fiber and aramid, and sometimes Technora or Dyneema as well.
Okay.
For cruising boats you would do Dyneema. For racing boats you would put some carbon, some Kevlar or aramid fiber, as they are called.
Okay, and when you say taffeta, is that Dacron or what?
Taffeta is a very light Dacron or polyester fabric, almost from like spinnaker weight fabrics to heavier fabrics. And for a light-weighted sail you would put very light taffetas, and for a heavier sail you choose a heavier taffeta. It's for the chafing and the longer life of the sail.
Okay, so the taffeta kind of protects then the...
The taffeta kind of protects. It makes very little difference for the elongation or the stretch of the sail, but it's for the protection.
Okay, so now we've chosen the material, then how do you proceed with the design?
Well, from the previously made sails, we can look at the boat file. We have a database of 7,500 boats, and we have Katrina there in the database from earlier. We have all the sail measurements there, and we can look at the rig file. Sorry. We can, for instance, study the mast bend, which is crucial for the design. We can change within the boat base file. We can change, for instance, the main sheet tension, see how it influences the loads, and the sailcloth. We can also adjust the running backstay or the permanent backstay. Anything that there is on the boat can be adjusted, and we can see how it influences the sail while sailing. And this is also where we usually choose the sailcloth, so that if we would choose a Dacron cloth for the 8-meter, we would see that even quite a heavy Dacron would stretch too much. It would stretch almost 1% under the load, under the wind load. We can vary the wind load and see how it performs.
And 1% is too much then?
1% is definitely too much. Yeah.
Okay.
Yeah, like 0.5% is a lot already, and for racing boats it's quite a lot less. We want to go for one design boats. You want to go down to almost 0.1%.
Okay, sounds pretty amazing. Yes.
Yeah.
Okay.
These new materials are quite amazing. But
Okay.
as you can see, 20,000 Danish carbon aramid, the stretch will be only 0.2%. So that's the fabric that we are choosing from our experience from similar boats before.
Okay. So what's the mix, carbon versus aramid?
It would be about 30% of the carbon and 70% aramid
Okay.
in this case. For a very completely racing oriented, it could be swapped
Okay.
the other way around, 70% carbon, up to 70% carbon and 30% of aramid. But
Okay.
the aramid is more resisting to bending.
So it will last longer.
Yeah, it will last longer. It will be a better choice.
Okay.
And you can add the amount of the fibers to compensate for the stretch anyway. So
Okay.
it's a choice to make between the long-lasting and a little bit the weight of the sail as well.
Okay. So sail design is much more science than art then.
It's still a little bit art, but it's
Okay.
it's the science part of it has been taking big steps in the last 20 years or so.
Okay.
It's quite a lot. We can also look at the performance of the boat if you want. The boat base has a simple PPP program that can or that will generate performance powers for the boat in question, and from these powers we can read, mostly for the sail design you would read the apparent wind angles and also the wind range, that how well the boat carries its sails and so on.
Mm. And VPP stands for Velocity Prediction Program?
Yes, VPP
Right.
stands for.
Yes. So then, I mean, you have different wind speeds there. 12 meters is the biggest. So is there now, for the sail that you're designing now, is there a maximum wind speed that you're designing for?
There is, there is, but they actually, the 8 meters have a limit when they don't sail. I think it's 10 meters true.
For the
limit,
race,
the race, yeah. So,
okay, so you don't need to worry about
they don't
that.
You don't really have to. In this case, you don't have to worry about that. I could still show you if you want to some. Not for any individual designs, but sometimes we do projects where we do simulations, and for the Olympic racing boats and so on, we have done years and years of simulation work. But we have done it for the class R-meter boats also, more from the interest than really to improve the designs, but from our own interest to see how the sails and how the hulls perform.
So is the red color now the load?
The red color would be, yes, the pressure. It would be the pressure coefficient, and the white smoke is turbulence. Turbulence, which will be coming. In this we can see that the genoa is a bit too full.
Okay.
In the luff here, in the front part.
Because it's generating.
Because it's generating this
turbulence.
Turbulence on the windward side.
Okay.
And then there's plenty of turbulence from the deck and from the hull of the sail. And from the spreaders also, you can see. And here you can see the wave making of when the boat picks up speed, you can see the wave increases, and this work we have done for a very long time, and really lots of research trying to improve, to understand better how the sails and how the sailboats works, and that way improve our designs.
Okay.
So when we're happy with our basics for the design, we move on to a sail design program where we have already the 8 meter model is already ready here, and I want to start from beginning. The same thing applies here, that we have an existing model that we open, and then we can modify the existing model to fit exactly the demands of this customer and this boat.
So in this case, when you have now a Genoa drawn in there, do you know that is the Katrina Genoa?
That's the Katrina Genoa that we did last year, yes.
Okay, so you know for a fact that it looks like that.
Yeah,
okay,
that is
yes.
one of the Genoas that we did last year for
Right.
Katrina, and this is the new mainsail that is being made. And for the new mainsail, they want a little bit less roach than they had earlier, and also we've added some off curve. The design is flatter in the foot.
And
with
the reasons for this are?
The reasons for this are the general evolution in the meter boats and all kind of boats, and also the customer wishes.
Okay.
The customer, they know their boat quite well, and they think that they do well anyway in light winds. They want to perform better in medium and heavier winds.
Okay.
And so we discuss this with the customer, and we come to the conclusion that okay, we make a little bit, we don't make the maximum sail area, we make the sail a little bit smaller than the...
So mainly, is that then influencing heel and in heavy winds, or what is the sort of the benefit that you derive?
That is to influence heel, yeah.
Okay.
Yeah, that is to influence heel. And for the sail, you choose the balance, you choose the seam shaping, patches, thread layout, which is the layout of the stringing. It's called the stringing, the fibers.
Oh, that's the fibers now. Okay.
That's the fibers that you put into the sail, and you can. Well, if we choose the fiber layout here, you can measure the DPI in various parts of the sail, and you can modify it.
If you're now designing the layout of the fibers, it means that you can't just, take cloth off a roll.
No, in this case, we don't have we're a small sailboat. We don't have a stringing machine of our own. So we do the design here and send it to Italy or France, where we have
Subcontractors or
contractor, yeah,
or partners.
Partners. Exactly.
Yes, okay, partners. Yes.
We send the design to our partner in Italy or in France, and they do the lamination of the body of the sail for us and send us the finished body, and we then put the parts together and do the finish, corners and all the finishing layout for the membranes.
Okay, so it means that it's actually totally then tailored for this boat.
It's totally tailored for the boat, like almost any sail that we make,
Right,
except for the one design classes. For the one design classes, we have permanent designs, but even they are tailored. For instance, for the fin, they are tailored for the weight of the sailor and for his mast. So
Okay.
we make hardly any sails that are not exactly tailored. But in this case of the membranes, they are completely tailored because we make them that way.
So now, of course, I have to ask the question. So, I mean, this sounds, a different model than the classical Dacron where you just had a big roll. So, how does this compare price-wise to say, a good quality Dacron?
It's like 50% more expensive.
Okay.
So,
but it sounds reasonable. Okay.
Yeah, it's expensive, but the bigger the boat, the bigger the sail, the more economical it is to do it as a membrane.
Okay.
Because when the sail gets very big, and the cloth is just 150 centimeters wide, the number of the panels increases so much.
So the sewing work.
The labor, the sewing work, the cutting work and the sewing work increases so much that actually when the sails grow bigger, at some point the membrane is even less expensive to make than the...
So now the material comes back from your partner in say Italy or France, and then you start putting the sail together.
Yes. Then you proceed to the sail goes into the loft, and you proceed with the fabrication of the sail. It doesn't come in one piece actually. We prefer to have, because the I'll take it from here. The membrane is done in 5 pieces in this case. Okay. And it comes in 5 pieces so that it's easier for the transport. It will be a very big sail, one together, and it would have to be folded so many times. So we take it in pieces here, and also we are sure that the quality of the sail is what we want. when we assemble it here. We have an ultrasound seaming machine that it's not stitch. When we put the pieces together, it's one single membrane in one piece.
Okay.
But we like to do that here rather than have it done in Italy or in France, because then we are quite sure that the quality is what we want.
So how are the panels then put together? Is it glue, or is it how do they?
It's in case of the membrane and in case of most laminate cells, it's not stitching, but it's actually it's a glue that is activated with the ultrasound.
Okay.
On a machine that looks like a sewing machine, but it's an ultrasound machine.
Okay.
It goes, it's as if you were sewing it, stitching it, but there is no thread, there are no holes in the sail, and it holds better. Because in this kind of laminate fabrics, the stitching is not very good. It's slippery.
Ah, so okay, is that the place where it would then kind of stretch?
It would stretch, yeah.
Ah, okay.
So you want to have the ultrasound machine for the assembly of all the cells.
So the seams are like, extremely stable.
Yeah.
Okay.
Yeah. In case of these taffeta membranes, it's not as important, but in film cells, it's a must, because you can't stitch film to film.
Okay.
It won't hold.
Okay.
The film is breaks so easily that you have to use the ultrasound.
Okay, so then you put together the whole sail, then something else.
Yeah. Then there's all the button pockets, the details, the dacrons for the corners. In the membrane cells, there is very little reinforcement, but you have to put some dacron under the ring so that you can fasten the ring into the sail.
Okay.
And then there's the sail numbering, luff tape, reach lines, cleats for the reach lines, and headboard for that finishing work. So that's how the sail comes out. I think we can later see how it happens in the real world when the sail is finished.
Good. But hey, this was great. Thanks a lot, Mikko, for this thing, and I think then the video will be showing some of this development steps, or the sort of the sail making steps that as well. So thanks.
Thank you.